Today we'll be talking about Immuta's integration with Google BigQuery. Immuta allows organizations to simplify, scale, and automate their data access and security workflows by enabling organizations to discover, secure, and detect abnormal data usage. To begin, let's look at Google BigQuery's editor page. On this page, you will notice we are looking at a patient data set that contains a lot of sensitive information. During this demo, we will see how Immuta allows organizations to find this sensitive data, protect it, and then audit what policies are applied against it. Next, let's take a look at the Immuta UI. This is the main landing page in Immuta. A patient's COVID table has been registered, and my current user is listed as the owner. When you log into Immuta, you will see any sources that you are responsible for, what sources you currently can access, and any sources that allow you to request access. If we click into the patient's COVID table, we will see the main landing page for this data source. This landing page is a great place to put descriptive information about the source. Immuta can also pull existing metadata from a catalog solution, like Elation. Switching into the Members tab, you will quickly see the users with select access to this data in Google BigQuery. One of the values Immuta provides is the ability to quickly discover who has access to a table and why. 2 users listed here are subscribed by a policy. That means a policy in Immuta has granted them access based on a specific criteria. If we switch to the Policies tab, we will see what criteria these users met for access. At the top of the Policies page, you can see the criteria for a subscription policy. A subscription policy is an Immuta policy that controls select access. In this case, any user who's a member of the group name healthcare provider will automatically be granted select access. Users don't have to wonder who can access that group, as the previous page showed the users who met this criteria. Currently, there are no data policies set. We will create a data policy later in this demo to illustrate how data policies can change the data returned to users. Next, we will switch to the Data Dictionary tab on the data source. This is where Immuta will display the classification detected during automatic sensitive data discovery. Notice the tags that are associated with each column. SDD automatically suggested the tags listed here. SDD runs pattern matches on the underlying data to find potentially sensitive data. This tagging allows organizations to write policies with context as why it should be applied. For example, now that Immuta has classified all the data, you can write a policy that spans all tables in BigQuery. If we need to mask all data that is personally identifiable, we can do that with a single policy, which we'll see later. If you click on a tag in Immuta, you will see details about where the information came from. Immuta's SDD classified this PII tag, but this tag could easily be pulled from a third-party catalog solution like Elation. Note, there's already a policy created that uses this tag. Let's take a look at how to create a policy in Immuta. Here you can see the subscription policy we discussed earlier. The Allow Health Providers to Access Health Data policy is what granted our users select access to this table earlier. Note how easy to understand the policy logic for this is. You can see that this subscription policy is automatically granting access to any PHI data for users in the healthcare provider group. This one policy can now grant access to any number of tables in BigQuery or any other platform that is supported by Immuta. Switching into the Data Policies tab, you can see many staged policies. These policies are not currently active. We will start by activating a policy that masks PII and Social Security number data in our data platforms. Let's look at the policy editor page to see how these policies are created. Immuta's secure engine allows users to build policies in an understandable way. These policies can apply dynamically based on classifications. In this example, you can see that we are masking all PII data with a hash and masking Social Security number with a constant value of redacted. Once we've defined these rules, you can see that we're applying this policy anywhere Immuta finds PII or Social Security number. This one policy is now protecting all tables that contain this type of information across many platforms. Now, if we go back to the policies page of the patient's COVID table, we can see what policy is applied. Again, note how easy to understand this policy is. Without Immuta, users would have to sift through SQL code to understand what's happening. Now we can rerun our query in Google BigQuery and see how the output changes. Notice that numeric PII fields are null, Social Security number is now redacted, and driver's number is hashed. Immuta's secure policy created this implementation. Users can continue using data directly in BigQuery, and the policies set in Immuta will continue to work and apply to any table that meets this criteria. Back in Immuta, we can look at the audit page to determine who is responsible for enabling or modifying policy. Immuta provides pre-canned reports that allow organizations to audit who is running queries, who is applying policies, and what data is being accessed. Immuta's new Detect product also supports active query monitoring and threat profiling. This support will be coming later this year or early next year. Thanks for taking the time to watch this video today. For any questions or to request a demo, please follow the links in the description.